Right. Hi, everyone. Right. Let's just switch over to our screen sharing and then we can start the talk in earnest. Right. Oh, hang on. Sorry. Bit of a right. Sorry. Just realized I might need my notes. Okay. Right. There you go. Uh, right. Okay. Oh, this could be quite interesting. Right. Okay. Right. Hello, everyone. My name is Sta Ana. I'm the London Rust user group organizer. I'm also part of the Rust community team. But tonight, I'm going to be talking to you about the Rust language server. Now, if you just give me a moment, I'm just firing up my other laptop. And there. Right. Okay. So tonight, we're going to be talking about what RLS is, the Rust language server. It's interesting and colourful history, a quick introduction to the main team, and then finally, with a bit of luck, as long as the demo gods don't get angry, we'll do a quick setup and whistle stop tour around the RLS using VS Code. Okay, so I guess the first question is, what is the Rust language server? Well, it's an implementation of the language server protocol. So you can imagine what the next slide is going to be. What is the language server protocol? Right, so hopefully you've got your tech buzzword bingo cards ready, because there's going to be a lot of them. So it's the language server protocol is an open standard client server protocol. The clients in this case are a code editor or IDE, and they talk to a server, and the server in this case being a process that is aware of the programming language in question. They use JSON RPC as the transport layer, and best way to think about that is think of it like a REST API, which emits JSON over HTTP, whereas in this case, the usual means is standard IO. So, okay, that's great. That's a technical definition, but so why should we get so excited about the language server protocol? Well, it probably helps to understand what the problem is with language support. And by language support, what we mean there is that things like linting. So for example, as you're typing code, you can see whether you're doing syntax errors or anything like that. Being able to find or rename symbols. Symbols can be anything like a variable, function name, type definition, and of course formatting code. This is the minimum we expect to have for language support. So that's the slide to give some context. The language support for editors comes in two forms. You either get the giants like Microsoft, who do support for things like Visual Studio, or you get JetBrains. They do the language support for your favorite language, or it comes in the other form of third parties, i.e. yourself. So to give this screen some context, if you think about the top 5 languages, multiply that by top 5 editors, that's 25 permutations that you could have to have language support for an editor, or implementations if you want to think of it that way. And to make matters worse, there's no compatibility between the implementations. So for example, if you're using NeoVim or Vim, you're going to be probably using the Vim L scripting language, or in the case of Atom, you're going to be using JavaScript, Visual Studio Code, TypeScript, etc. So there's no reuse here, which is, we know this is a bad thing being developers. So what's the solution? Well, the solution is to have the editors implement LSP client, and the LSP itself is language agnostic, as we'll see in a moment. And then the core team implements language server, and this is exactly what's happened with Rust. They've created a language server that is aware of Rust and can respond to any client as long as it implements the LSP client protocol. So sounds a bit woolly at the moment, but let's see if we can go through a workflow, so it might help you understand how this language server protocol works. So we're going to go with what we would call a standard workflow. So the idea being is user's going to edit the document, and then they're going to kind of try to find some references to maybe a function or something like that. So if we look at at where we have it highlighted, the tool in this case is the client. So this is the editor or code editor or the IDE. On the right-hand side is the language server. So this is the process that the client's going to be talking to. Remember, it's talking over standard I/O. So the first step, the user opens the document, and what we're looking at here, you can see the arrows going towards the language server, and all it's doing is it's implementing a method called didOpen. Parameter it's passing is the document that's just been opened. Immediately, the language server is taken this information, loaded up the document. In this case, we frame this in the context of Rust. It's already starting to analyze this document and trying to say, right, is this compilable? Have I got any problems with this? It's building up a document model. So user starts to make some changes. Quite literally, every key you are typing is being fired back to the language server. So you're getting this immediate feedback. And in this case, we're sending a method called didChange. Again, passing off the document to say which one we're changing. At this point, if we made an error or something that caused a warning if you think in the Rust compiler, the language server is going to start firing back some information. So in this case, it's now sending us a response with diagnostics. And if you're familiar with things like, I think Eclipse and Visual Studio both do a similar kind of thing where there's a window that has problems and it shows you either syntax errors or compilation errors and warnings. And this is the kind of stuff that's being rendered back on your editor. So that pretty much completes opening a document, making some changes, getting some diagnostics. Next thing you might do within this session is you might say, okay, I want to see what does this function do? Where is it being defined? So in this case, it's a go to definition. And what happens is your cursor's on the position, you trigger the go to definition. This then in the back end sends a definition method call, which tells you the document again that we're manipulating, the position where the cursor is, and the server this time returns back a URI, which usually tends to be another bit of source code, in some case a library, and the range. The range is important because in some editors, you have the concept of a window, a little pop-up modal. So the idea being, rather than show you all the source code, it just shows you the relevant fragment. Finally, we close the user document, send another method over. As far as the language server is concerned, it makes sure it commits that to disk, removes it from the analysis, and then waits for the next event to take place. So this is the most common flow that you're going to see when interacting with the language server protocol. Okay, so next on, let's go through the history. Right, so yes, it does go back. The Rust language server goes back as far as 2014, which is prehistoric if you think about Rust. So what basically happened in October, a Rust plugin for DXR. Now, I suspect unless you work for Mozilla, most people aren't familiar with DXR. It's the source code search engine that's used internally by the Mozilla team. And the main reason they needed it is for their biggest project, which is Firefox. During this time, when the plugin was created to make it Rust aware, another important crate, you'd have missed this in the time in the history, save analysis. This is quite critical because as you're compiling the code, to be able to send off the analysis, to save the analysis, if you will, it allows us to be able to pass the code. And this is what when you open up the document and the language server is processing it, this is what's happening. It's using the save analysis to try to make decisions on whether this code is going to work or not. In 2015, September, Microsoft announces the language server protocol. We take this as the official commit because this is the first time it appears in GitHub. It could have been much earlier on, but obviously that's the first bit that the public are aware of. In October, the Rust team proposes a new tool called Oracle. And so you can imagine that's a bit of an unfortunate name. It's soon to be renamed to the Rust language server. Main reason being is there already is I think it's a support tool for the Go programming language, and also there's that famous database that people like to spend a lot of money on. Right. Roll on to 2016, and Rust W, which is a front end to the Rust C compiler, appears. This is significant because this will eventually bootstrap the RLS code. In June, Microsoft, along with Red Hat and CodeEnvy, make the language server protocol an open standard. Also around the same time, during the Rust team's world tour, they announced as part of their 2017 roadmap that they want to make a better experience for IDE use for Rust. Just after then, Jonathan Turner joins the RLS team, and then in August the Breaking of the Ground appears, and we have an official RLS code repo. Not too long after, in September, we get the Visual Studio Code extension. The reason why this is significant is that the RLS team decided to use Visual Studio as the reference editor for any kind of RLS troubleshooting. And it kind of makes sense because when Microsoft announced the language server protocol, their first implementation was in Visual Studio Code. So in actual fact, the extension itself really just implements the libraries and then adds on a few more extras to make it more Rust friendly. Roll on to 2017, and we get the alpha in January. And the reason why the alpha is so significant is that we pretty much have most of the functionality that we do expect for language support. Things like auto-completion, being able to go to definitions, finding all references, and even a bit of refactoring, allowing you to rename symbols. Around April time, the beta is released. Again, a bit more stability, but probably significant time was also that the RLS appears in Rustup. And the reason why this is significant is previously you would have had to git clone the repo, build the whole thing, and then start using RLS. Whereas now, Rustup, if you're not familiar with Rustup, that's our toolchain manager. Just allows you to add it, download it like another component, just like you would with source code or documentation. And then to end off the year in July, the reference extension makes an appearance in the marketplace, which means there's one less thing that you had to download from the GitHub. Right. So in the team, there is currently full-time Nick Cameron and Jonathan Turner. There's been at least one Google Summer of Code intern, Igor Matuszewski, and of course many other contributors like yourselves. So this is the part where we get to the live demo. I think I've kind of whizzed through that talk quite quickly, but let's see if I can show you what Rust looks like beforehand, and then show you what Visual Studio looks like beforehand, and then what it looks like after you've installed the extension. So got this one here. Right. So I'm using two versions of Visual Studio. The first one here is the bleeding edge one, which is called the Inside Edition. It's just a nice way for me to be able to show you what the editor looks like without the Rust extension. So as you can see already, just to check there, I'm just going to have a quick word with there we go. Right. So can everyone see the editor on screen at the moment?
Yep.
Okay, great. Right. So as I said before, this is the Inside Edition. So this is the bleeding edge one, but I don't mind it. It's fine because it can show you the basic functionality. So as you can see already, Visual Studio Code straight away already has it has some support. It knows that this is Rust. You get a bit of coloring, but things that you don't get are if you could see here, there's no kind of warning, no code sense. There's nothing here to indicate there's, let alone your completion at the moment is literally just what's in the buffer, what it's seen before, rather than actually stuff that's available in there. just escaped me now, but what's available within the RLS. So what we're going to do here is, in fact, I'm just going to prove one more thing. So if we do that, that should have caused a syntax error. But as you see, get a bit of color highlighting, but that's really all you get from Visual Studio Code. So providing you have Rust up already installed, and I think you may even get prompted if you don't have it installed, all you have to do is find the extension RLS. Unfortunately, there are a few other extensions there, but the one that you want is Rust and RLS in brackets. Do that. Okay. Oh, and then suddenly I'm getting all kinds of things now. I don't know if you can see here in the problems window, it's not now it's saying, the hell's that? I don't know what that is. Another thing here really quickly. I'm not going to give you too many of these things because I'm actually going through the code demo, but as you can see, all I had to do was install this extension, and straight away you can see that RLS is kicking in, and you've already got some assistance with your coding in Rust. Yep.
Zoom in the code a little bit, please.
Sure. Well, actually, what I'm going to do now, that was just to show you the extension, how to install it, and now I'm going to go to the proper live coding demo. Is that all right? Okay. All right, let's just... Right. Okay. Let's just do a quick check here. That big enough, the screen? The font big enough?
So, tiny bit more, maybe?
Yep, sure. How about that?
Yeah, I think that's better, thanks.
Okay, great. Right. Okay, so this is going to be the proper tour now of Rust up. So that was just to check the fonts. So first thing we're going to do is create. If you're not familiar with Cargo, that's the package manager. I mean, it does a lot more, but in essence, it's the package manager for Rust. And when we put the bin switch on, that basically means we're making console app. If you don't do that, by default, you create a library. Okay. And also you get a bit of boilerplate when you create the demo time. So, and the boilerplate happens to be hello world. So let's open that up now. Okay. Right. So just going to do this. And that way you can see the syntax errors as they happen. This is when I was referring to in the flow, when I was referring to diagnostics, this is usually where you see the errors. Also, what you want to probably pay attention to, now I'm on quite a fast computer. When I did this demo last time, I was on my really slow Airbook, so you could actually see the analysis taking place. But you may occasionally, if you look down at the RLS done on the bottom left-hand side, you'll occasionally see that doing analysis. But I suspect because this code is so simple, it may not happen. So let's give it a go anyway. Right, so first off, let's go create, let's do a bit of refactoring. Straight away, we can see we're getting some warnings. It's telling us we've not used this function. Let's move our naughty bit of code here. And if everyone can, I'll just do that again just to show you. Ooh. Bit of tab completion. You're going to see quite a lot of tab completion there. You can tell because that is tab completion rather than the kind of the buffer completion, because it's showing you it's a function. There's a few more details in there. Like example, you can see there the signature, which isn't particularly useful at the moment. We'll see some better examples shortly. I should probably explain now that the code examples I'm going to use here are first very simple. The idea being is if you've never seen Rust before, you don't have to spend too much time parsing what the heck we're doing. And at the same time, it also allows us, in some cases, you also see some bad practices, but that's done on purpose to, again, illustrate how you can have some assistance using RLS. So, okay, so the first off, we've refactored it. We've got the greeting method there. And again, as long as as long as we've got no problems, everything means it should be compiling. We don't even need to recompile. It's being compiled for us. So let's now start on new library. Simple, nothing exciting there. Okay. Again, bad practice, but there's a reason why. Okay, so you can see every time I'm typing a key, it's telling me if it's happy or not. And then in this case, let's do okay. So on that, and now let's do a little bit more demonstrations. So again, we're getting nagged. We're not using this code here. So let's just silence that a little bit. Just turn the noise down a little bit. And if we, just to show you a context of the type hints that you get. So in the case of here, greet, the signature is fairly simple. It's not going to return anything. But let's have a look at yo this time. And so first off, you can already see that there's it's obviously a function. It's not taking any parameters, but we know it's going to return an integer. Also, I don't know if you noticed that above it is the documentation tags that have appeared. We can go even one further now, and we can do a peek at the definition by holding down the command key. I think that's probably Control on Windows if you're using Visual Studio, and already we can have a quick preview to see what the definition of the yo is. And those people who are very observant will have noticed that there's a little underline there, which means if I want to, if I'm well holding down the command or the control, I can just click through and find it didn't work. There you go. Right, and you immediately go to library. So you can imagine if you've got loads of libraries and you just want to kind of jump through and see what the definition for that code is, you can just do it as easy as that. Right, so next thing is we're going to add another method to our library, and this is just to now demonstrate a new feature. Now we've got two public methods, and the people who've had some experience with Rust will know what this symbol here is. In fact, if you've used Python, you'll also be familiar with it. This is globbing, and generally, as a rule of thumb, you don't want to import everything in a library. You want to be a bit more selective, but when you start coding at first, it's a quick way without you having to remember what every method is. So we can actually fix that. So all we have to do is a new method there called Rust deglob imports, and suddenly it's expanded it out because it knows that there's yo. But if you'll notice there, anyone who's been very observant should have said, oh, okay, that's actually worked, because you might have expected no to also be being imported there, but no isn't in use at the moment. So just to prove that Bob's smart, I'm going to put that back in again. Okay, so this time, both of the functions being imported. So there you go. Those I've showed you some references of deglobbed. Let's go rename some stuff now. So in fact, I'm gonna do this. Deglob that again. Go back to yo. We don't like the name of yo. All we have to do is have the cursor on the function, or basically anything. This could be a variable basically it's a symbol. Let's add a bit more pirate to it. In a second, there's a little bit of a complaint there, but that's just no being told it's not being used. But let's go have a look then. And if we look at the main source code, you'll see now that the import's been renamed, and so has the function call in there. The next thing we're going to see is, let's have a look at the references. Again, this could be quite useful. You either might want to see where else am I using this function, and again, recall this was in the flow diagram. This was the bit where your cursor is in a certain position. The language server is now thrown back the URI with the documents which refer to that symbol, and not only that, they're giving you the range as well where that code is applicable to. So in the first case, the first definition, first reference you find is the definition itself, and then if you look in main source, you can see it was used as part of the import, and also used as part of the call to that function. Right. Okay, so nearing the end of our demo, let's just do this. There's one more feature. So I think we've covered most of the features. You've got linting, so you've got the errors, warnings of errors as you type. We've already seen that you can find and rename symbols. So the last trick, well, actually there's a few more, but the last trick that we would have expected for language support is the ability to format. So as you can see here, this might happen if you were to paste this in your code, but again, all you have to do is just do format document, and suddenly everything's back to normal. You can imagine sometimes if your paste goes wrong, this would be a lifesaver. I should probably point out that the source code formatting is using the standard Rust FTM tool, FMT tool even, and for code completion we're still using Racer at the moment, and also for references. If you've ever had to set up any kind of language support on your editor before, you'll be quite familiar with those, but in case you're wondering what happened, they're still being used, they're just being invoked at a library level. All right, so the last feature we have is, I don't know if anyone noticed, but as I was typing, you see some pop-ups appearing, and obviously these are buffer completion, or in this case, a snippet. So these are one of the example snippets, but let's use something a little bit more complicated, the insert loop. Now, what I'm doing here now is I'm just hitting tab to move to the placeholders. If you ever use snippets before, usually you find there's tab stops as you're filling out the code. And then do that, and then finally we can use print line vector, print line macro, and surprisingly, this will do very little. Oh yeah, actually, let's try saving that again. Oh, if you wanted to see what other snippets are available, the bunch here, we're always waiting for more snippets to be added. So if you want to contribute, there'll be some links later on towards the end of the slide. And finally, I think that is the demo. I'll just make sure I haven't forgot anything. Oh, one last thing. It's always right. As you create a new Rust project, or open it up in Visual Studio Code with RLS support built in, it automatically adds a bunch of build helpers, and so most of these should be quite obvious. But if you didn't want to open up the terminal and do the cargo run for whatever reason, you'll get some built-in tasks, and this does exactly the same thing I've just done in terminal, runs it there. And that's the end of that, and we can now go back to the slides, I hope. Right. Okay. Right, so we've done the RLS in action, and finally. Okay, so as you can gather, the language server protocol really does reduce the amount of time it takes to provide language support. It's probably something you want to look at if there's ever another language that you might be interested in, and the Rust team has exploited it heavily, and I think with great effect. Also, RLS, or Rust Language Server, has had an interesting history, a bit like Rust. I hope through my live demo of the Visual Studio Code and Rust Language Server, you might have got a feeling there that the user experience is pretty good. If you might be underwhelmed if you're used to Visual Studio and the tooling that comes there, but if you've ever come from the Vim background or had to basically get Rust language support without RLS, you'll know how difficult it can be. At the moment, it's currently good for small to medium-sized projects, and what that basically means is something like Diesel is considered a large project, isn't going to load very easily, but obviously that limitation is being whittled away. We're currently in preview, which is basically the release candidate. When I gave this talk last time, we were still in beta, so you can see that was in August, so we're moving at astonishing rate here. I'm pretty certain we're going to have version 1.0 before the end of 2017, and I think that's that. And then finally, I'm just going to show you this for a second, and basically that's got all the links, all the stuff I've been talking about. You should be able to find further information there, including the video slides of the stock photos. And I think once that's ready, I'll take that off the screen and I'll take some questions if there are any.
Any questions there?
I had a question. What kind of techniques are you using to support larger projects? Are you doing any like fuzzy parting, or are you just speeding up the handling in the current way?
Sorry, I'm just going to switch it over again. Right. Unfortunately, the bits I do know about the oh, hang on, it might help if I stop screen sharing there so you can see my my face again. Of the things, so I'm not actually doing any of the RLS development, but I do know the larger project things that are happening at the moment. There a lot of things are things like incremental compilation are being looked at. It's a problem because we know that generally Rust compilation can be slow at the moment, but yeah, sorry, I don't have a very good answer for that one.
That's right, thanks.
So, if I can just answer, I was at the incremental computation workshop in Barcelona. Unfortunately, they didn't have videos for that, but if you can find out who the speaker was, they had a talk on incremental compilation in Rust, which was somewhat interesting.
Thanks.
Security implications of using the language server protocol to communicate between our computer and the servers, and they scanning out our code.
Right. If I've understood it right there, so you're wondering about the network traffic going between the client and the server?
Yes, and once they are having access of everything that is going in the editor, can have security implications. So if somebody can break in.
Ah, right. Okay. So whilst you could you go over the network with LSP, all of this is being done locally on your machine. So RLS is actually running as a background process on your machine. The JSON RPC, the way it communicates, rather than going over HTTP, is literally standard input output. But beyond there, it doesn't dial home. It doesn't call anyone else. Doesn't send your code to be analyzed by by the mothership. So everything is there. You could turn off the network and it will still keep passing.
I understand wrongly. I was thinking that was over
Yeah.
to
Yeah.
Snow is running locally. Okay.
Yeah.
Cool.
Okay.
Is Racer supposed to be the long-term solution to code completion, or will the compiler be used for that later on?
I think at the moment in the immediate future, it's still going to be prevalent. I know it's basically what it comes down to is someone needs to rewrite something, implement Racer's features in Rust. But I think right now it does a really good job. Obviously the big things with Racer, the formatting tool, and any of the cargo functionality, we are using that at library level rather than doing something nasty like spawning a process. But yeah, you're right. At some point, that will probably be addressed. As to when, your guess is as good as mine. Yep.
If you have multiple projects open and multiple IDE, is it the same server, and how does this impact performances?
I missed the bit about the IDE. Which editor is this?
Multiple IDE like Visual Studio and something else, and you have multiple projects open in each of them.
Oh, okay. Oh, so the editor I was using, is that right?
Sorry?
Were you referring to the two code editors I was using?
Yes, you are using let's say that you have two separate code editor open and multiple projects in each of them. Is it one server that is handling all of them, or there is a server per project?
You know what? I'm not actually sure. You'd have to do some testing there. I think I'm assuming that because it's standard in, out, and in theory you've got. I think you'd have to test that. My gut feeling is that the RLS team would have thought about something like that, so you wouldn't have one editor giving wrong diagnostics to another, to one RLS process giving wrong diagnostics to another editor. But again, you might also ask what would be the use case for having the two editors open. I guess you might do if you're comparing source code. I don't know. That'd be an interesting test to find out. Right.
Okay, I don't think we have any more questions.
Okay, great.
So thank you so much, Mark, for joining us. That was great.
Thank you.
Yeah.
Welcome. Thanks for having me. And right. Bye everyone.
Bye. Thank you.
Thanks.